Thank you for coming, Chris. Give him a big round of applause. This is not the last time you'll see him up here. He'll be back up later today. But for now, let's talk about WarpDrive.
Thank you. Good morning. I'm Chris. You probably know me as Runspired. I lead the data team for Ember working on WarpDrive. I work at Autoboard, and I'd like to thank them for believing in and investing in our open source community. My talk today has kind of a funny title. It's a title that asks a lot of questions. Questions like, what is a Polaris app? Is Polaris here now? What does Polaris mean? Why does this title spell out MPAs? This talk will answer none of these questions. A year ago, when we unveiled WarpDrive, the universal successor to EmberData, we laid out a core mission to work equally well with or without any framework, with or without a DOM, in any JS runtime, with standard build tools, and even with any version of Ember. Our goal was to deliver an experience that would allow your products to maximize their success for at least the next decade of web development. This meant creating something that could grow with you, evolve with you, scale with you, something that solves the problems you have now, anticipates the problems you don't have yet, and at every turn empowers you to do more, not less. The landscape of web development is even more unstable now than ever before. LLMs and agentic coding are here to stay, but no one seems to know what exactly that means. So we need to build something timeless, something certain, something stable in the wind, something that perfectly predicts the future. And since that's impossible, we need something flexible enough to integrate well into development paradigms that are unknown today. Something that predicts your next need a little bit better than AI predicts the next word. This is a talk about what we delivered this last year, but it's also going to revisit a few of Ember's axioms. These will help us understand where WarpDrive is going. We focused our work primarily in three areas: eliminating boilerplate, developer experience, and universal reactivity. This year, we streamlined the onboarding experience and worked on simplifying the mental model for the library as a whole. Our primary investment was package unification. At its core, this RFC was about making everything about WarpDrive easier. Let's look at what this means for you. Before, the library had grown into a huge list of packages you needed to install, configure, and manage. This was especially arduous if you dropped EmberData, wanted native types, or adopted Vite. But now, the core experience is just three packages: WarpDrive Core, WarpDrive JSON API, and WarpDrive Ember. New ideas that aren't ready to spring into fully formed RFCs begin as experiments. If you decide to use an experiment, you will want to be comfortable with the idea that the experiment might be highly unstable, may not advance, could even be deleted at any time. Experiments are a great opportunity to reach out and engage in the design process and assist in implementation. Ideas that are fully baked go into the core packages. Features that will be useful to nearly all apps go into WarpDrive Core, while those that are only useful to some apps go into WarpDrive Utilities. The JSON API package is just a cache implementation, and we're hoping to bring it into Core over the coming years to keep things even simpler. Anything framework-specific goes in a framework-specific package. Generally, these should be tiny. We'll take a look at a few of them later. And finally, WarpDrive Legacy contains code that was previously deprecated from Core, but is being given a second, longer life to help you migrate. Let's talk about why we're adding this. Over the last decade, I've had the opportunity to watch some of the largest Ember apps thrive because of Ember stability. But I've also had to watch those apps grow into large legacy code bases that are difficult to work in, instead of fun, like Ember should be. There are a lot of contributing factors to this happening, most of which have nothing to do with Ember. But it still made me wonder, has stability without stagnation failed? Is it maybe a bad axiom? I could give the entire talk today on why my conclusion is that it has failed, and failed in more ways than just the specifics of our stability guarantees. Let's save that for dinner conversation later. For now, just know that I do still think it's a great idea, and it can help guide us. But I also think we all recognize that even if the framework itself has not stagnated, the community around it seems to have. And when I think about why that might be, and what we might do differently, I keep coming back to a few relatively simple ideas. The first of these is the onboarding experience. There are two ways people onboard to a framework, and right now, Ember is really bad at both. Either you pick it up as a weekend hobby, in which case our failure to discard cruft means that we're asking you to learn not just the latest, but a long history of decisions and patterns. Or you pick it up because you joined a company using Ember, in which case not only do you have to learn Ember's long history of decisions and patterns, but your company's history with those decisions and patterns as well. Neither of these is an enjoyable experience. Ember has great ideas, maybe even the best ideas. But if we want to win over users, we have to treat onboarding, learning, and documentation as our products. And that extends to what patterns and practices developers need to know and care about. Now, there are benefits to the tech debt. Ember's failure to clean up produces decades-long stability that helps companies find product market fit. But that tech debt eventually chokes those companies. I'd like to rectify this. And that brings me to the second idea I had for why the community stagnated. Ember asks companies to do small amounts of upgrades and maintenance on a continual basis in exchange for hopefully never hitting a cliff over which they cannot upgrade. But what we find in practice is both that these cliffs still happen, maybe less frequently, and that very few companies achieve this style of maintenance or even have the need for it. Long-tail deprecation cycles and stability benefit long-running projects, but most apps don't achieve long-term success. Apps that do achieve long-term success don't care about this style of maintenance until late into their history, perhaps too late. And most of the apps that should do this style of maintenance still don't. If they upgrade at all, they do it in boom-bust waterfall cycles. So by prioritizing projects that are more rare, and a development modality that these rare projects often don't adhere to, we've traded a lot for a little. New apps, they face the cruft that is out there to support the old apps. Paradigms are muddled, messaging gets more confusing, the project's own maintenance and evolution get harder. And of course, these aren't just human problems anymore. LLMs and coding agents struggle to understand what patterns they should prefer when a literal decade of patterns is available in the codebase and supported and documented by the framework. The new flow that package unification offers us provides us a new mechanism for stability that I think answers many of these issues in a way that helps both the project and apps avoid stagnation. New apps never install legacy, and thus there is no cruft to consider. New features in the library are never impacted by code that supports legacy, as it lives in a separate package. When apps do upgrade and resolve deprecations, we've given them multiple ways through which to guarantee those patterns and that code never comes back. We've given ourselves the ability to move more swiftly in core when needed, and apps a clearer line about when it's time to start moving on. It becomes easy to segment documentation for LLMs based on what is experimental, what is recommended, what is deprecated, and what is legacy. We'll talk more about that in a moment. For now, let's look more at how package unification is helping solve these problems. Before package unification, the build config was a separate package you needed to know to install. Now it's included. The advantage here is a lot more clear when we see how this affects apps built with Vite, without support for Ember Classic. When using Vite, you have to configure embroider macros with WarpDrive's config. But pretty often it's the case that WarpDrive ends up being the only macros you are configuring, especially when configuring for a framework other than Ember. So we made the common case Babel configuration even simpler, though we document both approaches. Of course, installation and build configuration are just the beginning. If you've been following along with the evolution of WarpDrive, you've probably caught on to the idea that you're supposed to configure your store. In fact, this is what EmberData Store has been doing for folks all along. And so once you didn't want it, what it offered, suddenly things seemed really complicated. Just duplicating the configuration takes 68 lines of code with 22 imports from 10 different modules. If you configure for a fully modern Polaris experience, it's a little bit less. If you configure for the migration between legacy and Polaris, it's a lot more. And this is what it looks like before you start adding in code for newer features, such as cache policy. If you watched my talk at Emberfest a year ago, you may remember I mentioned that all of this boilerplate was something we wanted to eliminate. But it's also worth asking, how did we end up needing to do all of this in the first place? Which brings us to a good point to talk about the second one of those axioms I mentioned. Is convention over configuration really the ideal that we made it out to be? Convention is one of the most important tools through which we bring stability. But if we aren't careful, convention is also what causes the most stagnation. What went wrong here is that the initial conventions hindered configuration. And in doing so, it made it harder for the library to evolve. App re-exports hid what was going on. Container instantiation of services prevented passing config to the constructor. Class-based configuration resulted in expensive, extensive, and inflexible subclassing. Suddenly, in order to make small changes or provide small amounts of configuration, the library was stuck with no good options, which resulted in the creation of a new base class that needed to be configured differently depending on which conventions and features an app needed. Every choice here is a choice an app should be able to make. But it's not usually a choice the app needs to make. Taking a step back, we asked how we could support the most common configurations with less boilerplate while still enabling access to configuration when needed. The result is a function that takes in any necessary configuration, or rather two functions, one for the current core experience and one for legacy. This doesn't just work well for modern and legacy setups. It works for migration setups as well. It even makes it easier to add in model fragment support. We'll talk about that more in the workshop later. I think this is an important lesson. Convention is only as good as your ability to configure. Our axiom shouldn't mean convention instead of configuration. It should mean convention of configuration. I think we've seen the ramifications of not heeding this lesson play out across all levels of the Ember ecosystem. When we lose the ability to configure, we lose the flexibility we need to evolve as a framework, and our users lose the flexibility to solve critical business needs. Configuration is good. Should we eliminate some more of the boilerplate? The new packages use a stable types publishing strategy. The types just work. If you have the package installed, you will get type benefits. This means you can delete all of this config from your TS config. So that's boilerplate, eliminated, which helps us to deliver a great onboarding and upgrading experience for Polaris apps using WarpDrive. But it's far from the only developer experience improvement that we made this year. A lot of work has gone into refining the TypeScript story. Shipping public types is a relatively new thing for WarpDrive, and there's still a lot that could be better and cleaned up. But here's a few things we focused on. We tried to make imports more predictable by shortening their module paths and exporting them alongside other APIs they would typically be used with in order to reduce the total number of imports and improve editor suggestions. While we've made a lot of improvements in this area, this is one where I think there's still a lot of low-hanging fruit. If you encounter something that feels unexpected or verbose, please open a ticket or a PR to reduce that friction. We've also worked to clean up the names of various types to help unify the mental model of how things relate. For instance, a resource has cache data. It's resource data. It has a cache key, the resource key. It has a name, the resource type. It has a schema, the resource schema. It has a reactive representation, the reactive resource. And an array of reactive resources is a reactive resource array. Our biggest investment was in documentation. For several years now, we've been adding new Markdown guides to the repository and adding inline code documentation to types and other public APIs. But due to our use of YUIDoc, much of this documentation couldn't be published to Ember's documentation site. And due to YUIDoc's conventions, most of what we documented would not appear as inline documentation in your editor. So we finally ripped off the Band-Aid and converted all of the inline documentation to TSDoc. Together with TypeScript, TSDoc allows us to provide extensive documentation at your fingertips in your editor. Combining these with TypeDoc allows us to compile the inline documentation into Markdown, which we ingest with vpress together with those Markdown guides that we had in the repository. Together, this powers a powerful new documentation pipeline that is easy to extend with plugins to provide an even richer web-optimized experience for learning about WarpDrive. This new pipeline deploys updated docs for every commit to the main Canary doc site. There's also a more stable version for the current release on the main site. And because everything is an in-repo artifact, we'll be able to set up properly versioned docs. So even though there is no versioning at the moment, don't worry, we will be bringing that back. I mentioned this is a pluggable pipeline. A few of the pipeline plugins that we use are worth calling out. We process all of the human documentation into LLM optimized documentation, which you can quickly feed to your agents. This documentation is something we have plans to improve by teaching the pipeline to understand experiments, deprecations, and legacy separate from the recommended experience. This means that you'll be able to ask your LLM targeted questions based on your needs with less risk of getting an answer based on patterns that are no longer recommended. That is perhaps the most beautiful thing about these docs. While they are great for humans at every layer, from types to inline suggestions and inline docs to human optimized documentation, they're even better for LLMs. The age of agentic coding is here, and WarpDrive is primed for it. LLMs and 10-year vision are something that played into the design of package unification because signal quality matters. Of course, channels aren't the only way we can improve this signal. And this pipeline already has the ability for us to feed it additional LLM-only content, or even to exclude certain human-only content from it, ensuring that we can continuously refine the experience. If your LLM can't figure out the right answer when using these docs, please treat that as an issue-worthy occurrence, because together we can fight slop. A final call out on the docs. All of the examples have a button for quick copy-paste. But types and docs were not the only big change to DX this year. We also quietly launched a few features that I think are foundational to the WarpDrive experience, which will grow to become significant value propositions. We've been adding debugging instrumentation to the internals for the past several years. But now that information is grouped and formatted more intelligently and easier to activate from the DevTools. Sometimes it can take a little tuning to figure out what it was that you wanted to log to help you debug, but nearly everything the internals does is instrumented in some way that could be surfaced with logging. Over time, I want to add the ability to activate logs based on matching filters and integrate this information with a new inspector experience. One key thing about this instrumentation is that all of the data it logs is cloned at the point in time it logs. This prevents later mutations from meddling with your ability to debug and trace what occurred. We've built an intelligent schema-aware payload validator into WarpDrive that catches a large number of common but subtle mistakes that are otherwise incredibly hard to debug. It pretty prints the JSON of your response with inline annotations of everything it found wrong and whether the issue is a warning or an error. For many mistakes, It's able to use fuzzy matching to guide you towards what you likely intended to do to help you fix the mistake. Every time the validator catches something, it catches it at the moment the mistake occurred, instead of you trying to do a much more difficult backwards trace of why something isn't rendering correctly later. Eventually, in a future release, these errors will be thrown, but that's a feature that you can go ahead and opt into today if you wanted. It's already providing a huge amount of value to even very experienced devs, and there are still a lot of high-value features that we plan to add to it that will catch even more common mistakes. And finally, we shipped the first public canary of Holodeck. For years, WarpDrive and before it, EmberData offered a solution for managing data in your app, but not one for managing data in your test suite. We believe a comprehensive solution for data should help you write tests that use that data with the same focus on DX, performance, and scalability. Holodeck will be our solution for this. Currently, Holodeck implements just the bare bones of setup and replay for individual requests. But if you're curious to hear more, please ask me over dinner. There's a much grander feature set and vision that will make Holodeck unlike anything else, and make it a massively productive experience for apps of all sizes, especially when working with AI. So that's what we shipped this year in developer experience. And we're not done. We're going to keep making each of these better all the time. Let's talk about reactivity. First, the boring stuff. We finally shipped reactive resource. We previously called this schema model or schema record, but in keeping with our general theme of simplifying our terminology and concepts, we've settled on reactive resource. Reactive, because any state you access is backed by fine-grained signals-based reactivity. Resource, because it turns a resource from your API into a richer, deeply reactive object. Let's say that you had the resource type user and this resource data. Notice the dasherized keys, the numerical timestamp, and that our relationships have fields in them that are references to other resources. We probably want the reactive resource representation of this to look a bit more like the type on our right. We have our ID, the fields are flattened and camel case, the relationships provide direct access to the other reactive resources, and our timestamp is now an immutable datetime instance. How do we do this? We implement a resource schema for the user, describing each of its fields and how it should appear on our reactive resource. You'll notice we use legacy mode on this resources schema. Reactive resource has two modes, legacy and Polaris. I'll talk more about legacy mode in the workshop later today, and you'll hear a lot more about reactive resource in the talks from Kristen and Mehul tomorrow. For now, here's a quick summary. The most crucial differences are that you will want to target legacy mode for migrations in order to maximize compatibility with your existing code, and that Polaris mode is not quite fully ready for adoption. Polaris mode is not default yet for a few reasons. First, on models, record state had too many states. We needed to see what folks actually needed, especially in a world where requests had taken on many of the responsibilities that those states had before. We do need some reactive state defaults though, like is new and is dirty. We're also going to want some utils to make rollback quick and easy, probably as standalone functions similar to checkout and commit, see the docs, and not as methods on the record. But most importantly, we plan a significant rework around how relationships work to align them with how you use requests. We haven't completed this work yet. In short, there's a lot there, but there's a lot still to do. But so for the moment, we still think people should be targeting legacy mode while we finish policing Polaris mode. This year, we also shipped the ability to configure what signals WarpDrive uses. If you listened to Nick's talk before mine, you've seen some of what I'm about to show here. This is the entirety of the code that makes WarpDrive work with both of Ember's reactivity systems simultaneously, classic computed observers and Octane's tracked properties. This is the configuration for React. Now Svelte, now Ember with just tracked. Here is Vue, here's TC39 signals. And the cool thing is that you could support all of these frameworks simultaneously on the same page if you wanted to, just by composing these configurations. Configuring this reactivity is all that adding import WarpDrive Ember install at the top of your app does. What this means is that WarpDrive could provide a signal and a memo decorator that works universally across frameworks. We know this because internally we already do this. And doing this opens up a fascinating new world about how platform teams could support multiple frameworks, especially those that create a lot of state-heavy components. We know this because that's what WarpDrive itself is doing. Here's the view example. I'm going to hand wave this a bit. Right now, it's about half the file length of the React and Ember implementations. That's because it's missing a few features, and there's a lot of types cleanup to do. The main things to notice: this component doesn't manage any state. It concerns itself with setting up a request subscription, or a reactive state engine, based on the args that it receives when it's mounted. It replaces that subscription only when necessary. It destroys this subscription on dismount, and then it renders the state of the engine. None of the complex logic is handled by this component. That's one half of what ensures that the WarpDrive component features that we care about end up being a feature in every framework that we add. The other half is that because these components are all consuming reactive state, and because the only difference is which framework they are using to render and nothing else, we literally run the same tests on both our Ember implementation and our React implementation, with the test just swapping out which render function it calls with the provided usage. And that's universal reactivity. React shipped in 5.7. In closing, I look at Polaris as an ideology more than an addition. It has become the identity of the mission both Ember and WarpDrive share. It has two core principles: use the platform and embrace the ecosystem. Both of these work to ensure maximum flexibility when it comes time to make hard decisions about how we build and architect our apps and what technologies we choose. That flexibility extends to ensuring that we can build apps as multi-page applications, multi-framework applications, and even, as I suspect we will soon find, multi-platform applications. It would be irresponsible to expect that a company will not adopt or inherit other front-end technologies as it grows. These are events that we should be helping to optimize for, not shy away from. And similarly, it would be irresponsible to assume that an application can remain as a single ever-growing SPA monolith as it builds out its feature set. We have to expect that products that reach scale need seamless splitting and interop across product and organizational boundaries. Polaris is a hello world moment. It's no longer about Ember CLI. It's about plugging into any build. It's no longer about EmberData. It's about being a reactive state framework. It's no longer about Ember's reactivity. It's about cross-compatible signals. It's no longer just about Ember. Thanks.